We'll get rolling. So welcome to Intent-Based Networking with Cisco DNA. This session is designed to be an overview of intent-based networking, really talk about the DNA architecture, and as we were discussing earlier over here, let's land the plane on how these things kind of fit together architecturally, and hopefully talk about all these buzzwords and three-letter acronyms and turn them into something tangible. We'll actually get into some real demos at the end and talk about this concept of intent. I'm Mark Montañez. I'm a distinguished engineer in Cisco IT. So I lead the global team that is deploying DNAC, vManage, our software-defined access, software-defined WAN, the integration between them, and all of the base automation. So I'm planning right now a big global rollout of this technology. This time next year, I'll have 150 sites of Cisco's branch offices deployed in 2 of the major campuses, as we're right now in evaluations. We've got about 30 locations up, and we're actually using this technology. So I've got some hands-on experience and a whole bunch of thoughts about how we might deploy this at scale. And I'm joined by Mr. Matthias Faulkner.
Yeah, good afternoon. I'm Matt Faulkner. I'm a distinguished TME at Cisco, focused a lot on automation in the past few years, but spent some time in routing, virtualization as well. But my passion really right now is in intent-based networking and helping to evolve our networks to be a lot simpler, automated, aligned with the business.
Yep. So for the last 5 years, Matt and I were working on this DNA architecture. We were in the technology group when this was first being hatched, and got to do a lot of work on the initial workflows and even really the whole evolution of taking your intent and turning it into something in the network. So this is kind of the end of that journey where we get to see this turn into something real for people to adopt and turn on. So we're super excited to spend time with you guys today and drive through this. I'll fast forward by the abstract. Just want to make sure everybody's in the right place for where we plan. So here is our agenda for the day. All right, we want to spend a little bit of time talking about, well, why do we think you care about this whole automation and assurance intent-based networking paradigm, and dive into, hopefully have some time with you guys to go back and forth. Do these use cases and the kinds of things there really resonate with you? And if not, tell us why. And if they do, even have a little conversation around how they apply to you. We'll talk about what this intent-based paradigm really is, and try to land that plane on what we mean when we say intent-based networking. And then Mr. Faulkner is going to take you through the whole architectural view of how you break this down.
Yeah, a little more detail on what do we do under the hood, what does that actually mean, and what does DNA Center give you when we talk about intent-based networking.
And in the end, we're going to spend some time with some use cases. So if we sacrificed enough chickens, the live DNA center that I've got running back in a lab will remain accessible, and we'll do some things like application policy and dive down into how we take high-level intent and turn it into physical configuration on some network elements and distribute that across the network.
And assure things, right?
Yeah, and assurance, right. All right, so there's our agenda. So let's get started with, why should you care about this thing called intent, and really what the transition that's going on is happening in the network. So how many of you have seen somewhere this whole concept of the network intuitive, right? It's been on all the slides, was in the keynote, your SEs are talking to you about it, right? The big thing that we want to do here in this session is give you a way to tie the technology that's going on and the whole technology stack back to this concept of the network intuitive. The network intuitive really is just a way to say, I have a set of infrastructure that I want to program with automation, and then I want to use all of the counters or detailed performance information that lives inside of that network, consume it through telemetry, run analytics against it, and turn all of the data encounters into insights, and measure against that intent that I expressed, and tune my network so that I really achieve that intent that I expressed early on. All right, so we'll go through a whole bunch of examples of that. Security is a great use case for this tying of automation, enabling features and functionality, consuming information that the network or telemetry is able to send to us, and then inform that automation side of the house to be able to take action. We'll talk through some examples of how something like encrypted traffic analytics could really make this vision of the network intuitive real for us. Now, the reason that the network intuitive has been brought forward, or this whole concept of tying automation to assurance, is really based on some big drivers at enterprise networking. Right? So 63 million new devices by 2020. Right? Are you guys today experiencing in your networks exponential growth in the number of endpoints? Yeah? Everybody kind of dealing with even these things showing up, wanting to get on Wi-Fi, and then what do you do about like the security posture associated with those things, or building HVAC, lights, door pads, all of these different devices coming into the network, making the networks that we support bigger, more network elements that we have to configure because we're putting in more APs, more switches, more routers to connect all of that stuff up. And as we go through the complexity of just building out our networks to support that, we're crossing that point where, as IT professionals, managing these things the way that we used to be able to manage them just isn't feasible. Right? So if you think about the evolution that's happened in the data center, we went from a point in time where, remember when you used to put the DVD in the server and like answer a whole bunch of questions? And eventually you came up with a server that was your base environment, and then you could start deploying applications on top of. Now in the data center, you like go to a menu someplace and pick small, medium, large, hit return, and really before you can get over to someplace to connect to it, that server is spun up and ready for you to start doing something with in the data center side of the house. So for the networking guys in the room, so imagine that I did hit medium and deployed a new application in the data center, and that application needs priority service across my global WAN. How long does it take you to provision new quality of service policies to prioritize that application across your network? Days? Weeks? Months? Right? It's a complex problem when we start thinking about all of the network elements and what it takes for us to scale across the rest of our enterprise. And what we want to bring to bear in this environment are sets of tools that allow us to keep up with the data center and the way those things are moving, and with the fact that we have this ever-growing network that we just can't manage by hand anymore, and bring automation to bear across it to really address this complexity thing. And then we need to be able to apply security at scale to our network. So today, back in the network that you manage at home, is there a spreadsheet someplace that has the IP address subnet and the type of users that are associated with that subnet in your network? Anybody? Someplace in the network you're keeping track of that, maybe in an IPAM tool somewhere. And the reason you do that is so that you can write security policy somewhere in a firewall against that set of users and know who's there, so then you can control their access to things, right? Every time you go create a new set of users because they have a new security policy, do you start at like that subnet and VLAN level of defining policy? So you create a new subnet for a new set of users in your network because you want to be able to apply policy against them? Does that resonate? Yeah. So that means if you're doing that, that you're really redesigning your network every time you have a new set of users or things that you want to put in a VLAN, because you start all the way at layer 2, right? What VLAN? What am I going to do about that VLAN? Is it get stretched across multiple access layer switches? What does that mean to spanning tree in my environment? What am I going to do about my default gateway protocol to make sure I have high availability? What am I going to do with my routing protocol to service that? That sure slows us down, right? On the networking side of the house, remember, we're trying to keep up with the application side where they hit, give me a new server, and it's there in a few seconds, maybe minutes, but it's up and ready to go. But we want to have our user space be just as dynamic. So we're looking at, in this environment, when we bring controllers and automation and tools like software-defined access to bear to this solution space so that we can separate the network infrastructure connectivity piece from the policy piece of our network. And so that as we address this requirement of increased complex security, we aren't bogged down from a network redesign and implementation perspective. So we're going to talk about how we break up those problems and apply technology to address these things. Besides complexity, the growth of your networks and the increased security posture, what are the other things that are top of mind for you guys in the networks that you're managing, growing, and caring for today? Anybody? No? They're shy, they fell asleep after too much of high carbs at lunch. Compliance, making sure that your policies that you expressed are actually turned on in the network, yeah? So we'll talk about how intent-based networks helps us make sure that that intent that we expressed is really being realized by the network, and assurance tools being a way for us to get there. So that's cool. Anybody else? So these are the big care-abouts then. These are the things we should explore and make sure that we're addressing in our solution. Awesome. So as I told you guys when I first started, my name is Mark Montañez. I've been at Cisco for 21 years. I started as a systems engineer in the sales organization in Denver, Colorado, and 21 years ago on my badge was this whole changing the way we work, live, learn, and play. And 21 years ago, that was a pretty audacious statement, right? At that point in time, we were barely making DECnet and AppleTalk networks talk on the same network, and starting to bring this thing called IP into enterprise environments. And lots of people were trying to get onto this thing called the internet and figure out how they could use it for commerce, right? Today, this is real, right? The network is in the middle of everything that we do, and it's driving the requirement for us to leverage the network at scale, but also rethink the way that we do business. So just think about the kinds of tools that you used to plan your trip to Cisco Live, right? And how much there's these complex technology stacks that allow you to do kind of self-service things and get onto the network and interact with or do business differently. And what we're seeing happen is that almost every industry is experiencing change in the way that they are delivering their services, and they're going through what we call digital transformations, where the way that customers want to consume the services that they offer require this big complex technology stack to be integrated so that people can do this same kind of self-service experience that we talked about real simply in the data center, you know, small, medium, large, here's my server. Now think about how you consume services today and what the kinds of transitions that we've seen happening in the industry. Now what's really interesting here is if you as a provider of services don't change to the way that your customers want to consume your service, somebody else will offer it to them in a way that they want to, and they will move, right? So all of the great examples of digital transformation and how whole industries have been changed are real. What we want to do with intent-based networking and the DNA network is to help you guys as IT professionals thinking about the enterprise network, route switch wireless, and the way you provide connectivity. Take those simple things that you do every day to keep the lights on and automate those and let them become super simple and easy so that you can spend your time thinking about how your organization can react to these kinds of changes, and so that you can become an enabler for those changes instead of the IT guy saying, it's going to take 6 months or it's going to take a year to do those things, so that you can provide services at the scale and rate that your organization needs to be able to deliver these services. Right, so a couple of statements from industry analysts, both the IDC and Gartner, about this kind of change. What we're hearing from the industry is that customers want to change. They want to embrace this digital transformation, and they believe that it's going to be really important for them to do this. We also hear that this is hard, right? You have to retool, you have to rethink what you're doing. You have to change the way that you operate your networks, and that's an interesting transition that customers are going through as they try to embrace this automation, especially in the enterprise networking space. Now, the DNA architecture that we're going to dive deep into is designed to change some fundamental things about the way that we deploy these enterprise networks. Right? So we're moving from hardware-centric. Well, the boxes are still really important, and we love our hardware, UADP ASIC. I could spend a whole long time talking about how programmable hardware makes all of this transition important, and why the pieces of hardware or the ASICs that live inside of those Catalyst 93, 94, 9500 switches are awesome. It really is more important now about how that programmable hardware is able to turn on new functionality for you and take existing networks that maybe didn't know how to do VXLAN, therefore they couldn't do fabrics like SDA, and with a software upgrade to those switches, enable that functionality so that now your controller is able to build an overlay and underlay, separate out connectivity from policy, and allow you to do policy at scale. Moving away from manual kind of copy-paste or script-based configuration to automation driven by a controller where you express your intent. Something as simple as these applications are important to me, these applications are not important to me, and let the controller translate that into quality of service configurations that are specific to the wireless space, specific to your routers, and specific to your switching, and give you end-to-end across that full deployment, the right level of marking and servicing, where all you did is at a very high level say, these apps are important, these apps not so much, and let the controller step forward and handle all of the complexity of quality of service associated with that. I'm going to come back to that example a whole bunch of times, and we'll actually share that at the end of the session, and I'll show you what I mean when I say these are important, these are not, and really how can we drag and drop or make some edits to express that policy and what it turns into in the network configuration. I've kind of beat the security horse to death a little bit here, but it's super important, right? Security can't be an afterthought, and security also can't be this thing that causes us to redesign our network from layer 2 up every time we have new security policy that we need to implement. We just can't scale to be able to make those changes and handle all of the other requirements that come in that space. Wow. Network monitoring, we want to make that go away. Who cares about a whole bunch of counters? We need insights. What do those counters and events happening in the network mean to us? And when we correlate those events, how do I find out really interesting information? Like we have a flash event every third Wednesday of the month, and that is trending so that it's growing 10% month over month. I can tell you that next month, on the second Wednesday or third Wednesday of the month, you're going to run out of DHCP addresses in this location of the network if you don't do something, right? Look ahead and tell you these kinds of trends are going to create problems for you in your network and allow you to then make proactive decisions about solving those problems. And analytics tools allows us to do that. I encourage you to take a look at the keynote and what we're doing with machine learning. There's some great examples there that JP, one of the Cisco fellows, got up and talked about where this technology is going and functionality that's coming in DNAC version 1.4 that'll ship middle of the summer, July-ish kind of time frame, that really make this analytics even better than what it is today. It's super powerful today to help you draw insights from the kinds of counters that normally would be locked away in all of those network elements. So 402% ROI. It looks like a pretty big number, right? And I wouldn't want to argue that number with any of you because I'm sure it could be variable in your environment. But the real point here is if you just apply common sense to the kinds of things that we're doing in our enterprise networks today, right? Adds, moves, and changes, the kind of stuff that we do all day, every day to keep the lights on in the network we're running, that costs you real money in terms of people and time. And if you automate those things that are simple and you shouldn't be spending your time doing, that the machine can do better for you and keep consistent and avoid mistakes that humans make, there's a huge ROI in the things that we're turning on here and the ability to embrace automation. And that's really the point. Free you guys up from doing all of the menial tasks, right? The not so exciting. Like, it's not so fun to handle EIGRP fine-tuning these days, spinning the knobs for nerds. It's much more interesting to go work on how the network can enable digital transformation. So we're trying to get you out of spinning the knobs for nerds and really spend time on the more important business things. And there's real return on that if we automate those things that should be simple, should be consistent, and should just be there all the time in your network rather than kind of moving and changing all the time. Yeah. All right. So to do this, we're going to embrace software-defined networking, but we're not like going to take the textbook definition of software-defined networking. Right? We're not going to throw away 35 years of networking knowledge and experience and success with the big distributed systems that all of you have running today and take all that intelligence and put it in some God box in the network and then hope that things work. Right? We want to leverage all the intelligence that lives in all your routers and switches and APs in the environment that you've already built, because we know from experience that having individual network elements that have the ability to make autonomous decisions themselves, so converge around a link or node failure, prioritize the right traffic, provide security enforcement at that location, that's what's required to really have resilient, always-on networks. That's why the internet works. We have these distributed systems that have their own intelligence and are able to do what we tell them to do. The challenge with that big distributed system is keeping it aligned with your intent, right? We don't really give you tools before things like DNAC for you even to express your intent. So if you think about a very basic enterprise campus network, and you need to make decisions to turn that network or configure that network so that it's going to converge sub-second. You need to have the intent in your head that you want sub-second convergence, and then figure out what it is that you're going to do with your spanning tree environment. So you're going to span VLANs across multiple access layer switches? Are you going to limit those to a single access layer? What are you going to do about how you lay out your VLANs and IP subnetting that results in what's going to happen with spanning tree, and what features do you have to turn on at spanning tree at the access layer, distribution layer of your network? Then you have to figure out, based on that decision, what are you going to do about your default gateway redundancy? So am I going to use GLBP or HSRP, load balance, even odds between those. What am I going to do to make sure I use all my uplinks? Like all of a sudden, we've got two completely independent control planes, spanning tree and default gateway redundancy, that need to be linked together so that you send your traffic to the right active default gateway. And then what am I going to do about my routing protocol? Where do I summarize? How do I make sure that this thing all converges so that I can end up with a network that, if I have a link or a node failure, converges sub-second? All of that was holding intent in my head. Right now that we have tools like DNA Center, I can say I want a software-defined access fabric and allow the controller to provision all of that connectivity in my access layer switches, distribution layer switches, and core layer switches for me. And I didn't have to make a bunch of decisions about what was I going to do with spanning tree, or what was I going to do about route summarization. The controller lays down these configurations for us based on our intent to say, I want a fabric that converges sub-second. That's a transition to intent-based, and we do that through the application of policies. And really, policies, we're going to talk a bunch about security policies or access policies and how we enforce that security side. But the whole idea of this architecture, let you express your intent and then measure the results against that intent and tell you if you are aligned to that expressed intent, so that the thing that you previously held in your mind is actually what's happening in the network infrastructure when you move to this transition and start to leverage the controller to implement solutions in this space. So what is intent-based networking? Right? Intent-based networking is the industry term that is being adopted by all of the industry pundits, and they're focused on how do they put a more generic spin on the things that I just talked about from the DNA architecture. Right? And you can see from all of the industry pundits that they're saying this is super important. We think this is going to change the way that people build networks. And then they've even gone to the point of defining some new interesting terms, translate, automate, and assure, that pretty closely map to the conversation that we just talked about from a DNA architecture perspective around how we manage these things. So it's interesting to see that the industry is aligning to our story, and we can really map the things that we're talking about to what the industry pundits are calling this thing called intent-based networking, and how they're putting terms around the way that we take our intent and translate it into what we need the network to do, use the controller and automation to push that intent into the network infrastructure, and then measure the performance of that environment and make sure that the network is configured and executing against the intent that we expressed in our environment. And as we move back up the stack, right, the network intuitive is just another way to express that same concept of tell the network what you want it to do, measure the result of that coming back, and close the loop and make intelligent decisions based on being informed of what the network is doing. Now, a great example of this is rapid threat detection tied to the security stack, right? Recognize through telemetry that there's malware running on the network, inform the controller that you want to do something interesting to a user in that network, change that user's authentication into the network so that we now know that he's been infected and we want to apply some different policy to him. Maybe run him into a web page that lets him self-remediate, and when he's all cleaned up and clear and the network has sensed that again, moving back into the regular user environment. All stuff you can do today with DNAC and tools like StealthWatch that live in your network, automation that has existed now coming together to close that loop and show real application of the solutions in our environment. So to do all of that, we're going to embrace the digital network architecture. Right? The digital network architecture starts the bottom of the network with our programmable infrastructure, router switches, wireless APs. And we lead with programmable because it really is important that you're able to apply new functionality to these things as opposed to having to rip and replace them every time there's a requirement for new functionality. Right? So a couple of examples of that programmability would be the Catalyst 3850s and Catalyst 9Ks, the fact that those guys have something we call the U80P ASIC, right? So Unified Access Data Plane. That ASIC is a programmable data plane. What I mean by that is that we're able to change the firmware and teach it about new encapsulations. Right? So 3850s, there were about 2 million of them out in customers' networks. They didn't know how to speak VXLAN. They didn't know how to speak MPLS. 2 years ago, with a software upgrade, a new image of iOS XE for those devices, we were able to teach them how to handle new encapsulations. So we told them about VXLAN, and we told them about MPLS, and that gave us the building block to be able to build software-defined access fabrics, because now we could build VXLAN overlays and process that encapsulated traffic in hardware. Right? So that's one example. There's examples in the router side of the house and the wireless AP side of the house where the hardware that we're building is programmable and extensible based on changes in the infrastructure. The architecture embraces virtualization. That means that the network elements themselves are able to host other network services so that we can run functionality in the network where we need to run that. Examples of that are the Catalyst 9K that you can now run containers and put real functionality on the edge of the network, agents for application performance testing, run a sniffer in that access layer switch, and take a look at traffic right there rather than running out and plugging in your device on the wire there or trying to figure out a remote span kind of a thing, but actually running that application there. As we move up the stack, automation and analytics, right? Automation, DNAC, vManage, analytics, the tools inside of DNAC and vManage as well that give us the ability to both push configuration to the network elements based on your intent and consume the counters and run analytics against that, turning those counters into real insights into the network. And then at the top of the stack, this thing that we call cloud service management. This is really about how do we extend this architecture into the rest of IT. So integration via programmable interfaces, APIs, into things like ServiceNow, so that we can open cases in ServiceNow based on findings in the analytic tool, assign that to somebody, let them pick up that tool, and then when they solve the problem, also inform the network to take action about the kinds of things that they want to do in the network. So the ability to integrate and extend the functionality of these controllers into new and different use cases above and beyond the GUI, right? So DNA Center and vManage is the controller, SD-WAN, SD-Access, and Assurance, big solutions that are delivered on top of those controllers. Cat9Ks as the big thing that's really enabled this change at the access layer. How many people have heard of encrypted traffic analytics? A few folks around the room, right? So ETA, a way for us to digitally fingerprint malware on the network, and it's not just malware. We're digitally fingerprinting all of the traffic going through a switch, not breaking open the encryption, but looking at sequence of packet length and type, and exporting that via NetFlow out to the security stack. And the security stack is applying machine learning and can identify the difference between traffic flows on specific UDP ports or TCP ports that is something masquerading on your network. Right? So we all have like DNS open in our firewalls and allow DNS traffic to go in and out of the network. It's really easy to tell the difference between a real DNS transaction, even if it's encrypted, from one that is exporting a whole bunch of data out of your network, but has that using those same ports. So by taking that digital fingerprint, exporting it via NetFlow, then into the security stack, we're gaining visibility into malware running around the network and being able to use the security stack, things like StealthWatch, to inform us when bad things are happening on the network. So in a nutshell, that's encrypted traffic analytics. Top of the stack, we already talked about that, integrating with the rest of the network. The only other big point that I want to make across all of that is that we're closing that loop. So with that, Mr. Faulkner, you want to take us deeper into the architecture?
That was a nice setup, Mark. Thank
right,
you. What I wanted to do in the next 30 minutes or so is maybe give you a different view on what we mean by intent-based networking. When we first started with this pitch with our colleagues in marketing, we were in the architecture team and we thought, well, we're architects. We need a network kind of diagram because that's what you guys understand. And so we basically came up with a picture like that, and that's always our sort of reference map, if you will, of how we view enterprise networks. And hopefully you can relate to that. So what we see today still many times is that we have different types of sites here shown on the left. We focus a lot in enterprise networking, campus and branches, and the WAN. Really, our intent-based networking story today is focusing around software-defined access as a solution, so more in the campus space. But of course, many of you have WANs, hopefully adopting software-defined WAN, our Viptela solution. You run applications in your data centers, hopefully Cisco ACI. And probably you're going to move a lot more applications into cloud environments or consume them as a service. So that's kind of the more technical view of the network that we have in mind and that we then want to enable to become intent-based. So all of that is basically in the next slide abstracted behind a block that we call physical and virtual infrastructure. So if you see that, really that's what's behind it. So what we're trying to do with intent-based networking is basically align this network that we run in multiple domains a lot closer with the intent of your business. And in order to do that, we are focusing and enhancing the existing functionality by putting in an additional layer in our overall networking stack. And that's kind of the intent architecture. What's underneath that is really three main functions. Namely, first of all, a function that allows you to capture intent. And the focus here is more on abstractions and aligning this expression of intent with your business goals. Secondly, is improving upon our automation capabilities, so making sure that that intent that you've expressed can be automated and driven into your network elements, into the right elements, with the appropriate configurations. And very importantly is the third function that we're adding in an intent-based network, and that is assurance. So basically, the capability to continuously collect data from the network elements. But as Mark said, it's not good enough just to collect data and throw them back at you and say, you figure out what actually happened. We need to have in an intent-based networking really sophisticated mechanisms to interpret that data, derive meaningful insights, and ideally also then what we call close the loop is verify that that intent that you expressed is actually met by the metrics that you collected. And if it isn't, to help you remediate and suggest steps on how to get the intent back in line in case it isn't. So these three main functions. Let's look at them in a little more detail. So first of all, intent capture or intent translation. I actually think translation is a little bit of a misnomer here, because what this function actually entails is the capturing of your business intent. Today, as you'll see in a minute in DNA Center, we do that with user interfaces. So with graphical GUIs, where you operate DNA Center and you have a way to abstract intent, we'll show you an example of how to express a macro segmentation policy or a micro segmentation policy, as well as application policies. But this expression of intent could also be using natural language. We are thinking about maybe a way to do Alexa for networking. It might sound weird, but we actually have a tech fund project that experiments with that to receive voice commands and allow the expression of intent using natural language, or you can think of any other kind of syntax. So there's a syntax that aligns with your business that allows you to express what do I want the network to do. And the important thing here is to define what the network should do, not how it should do it. Now, obviously, there needs to be a function here as well in order to translate maybe that captured intent into something that's more machine understandable. Especially in my previous example, if we think about a user interface, then we need to turn that into internal models, let's say, that we can manipulate, that have a clear definition. So we create an abstraction of the intent. And then we have typically functions that are part of this intent translation capability that allows you to already do some integrity verification. So think about this. Maybe you have a large environment with multiple operators, and they all express intent. Who's to say that the intent that is being expressed is actually consistent among multiple operators? Or maybe consistent at different points in time. So we need to make sure that that intent that you express doesn't conflict with maybe existing intent expressions, and that is also part of that translation function. Now, maybe to delve into this topic a little bit deeper, one of the issues we get into, and you'll probably hear us more and more talk about more and more, is we need to have a much better awareness about the operational and the organizational structures that we're dealing with in a network. So maybe we'll have a team that expresses intent that is a network architecture team. A person network architecture like that may have different business needs and business aspirations and a different way of expressing intent than, let's say, a network administrator or somebody who's operating the network itself. So that awareness needs to be present as well in an intent-based network, that we can accommodate different organizational teams that all want to basically make sure that the network runs and aligns with the business. The other issue we have to contend here, and that's maybe a little bit of an elaboration on the actual translation function, is that when we try to express intent in an abstract manner, we actually introduce often some kind of ambiguity. And we as engineers don't usually like ambiguity. So here's some examples of great expressions of intent. Let's take a NetOps one in the middle here. The network should only have golden images deployed. So that may be something that you could say, well, yeah, that aligns with my business goal in my network operations, but it's also ambiguous. First of all, what does should mean? It's already softening up the statement. And then what is a golden image? Who defines the golden image? So that's also something to be aware of. I mean, on one side, we want to align with the business and do these abstractions, but by doing that, we're also running the risk of being more ambiguous and then having outcomes that maybe are not what you actually wanted to do. So that basically is the reason and the motivation why we need to be very careful in an intent-based network to not just allow abstract expressions, but still have quite well-defined translations underneath that you probably need to understand. Maybe coming back a little bit on this organizational structure, the network in an intent-based system needs to accommodate the different domains as well. So today what we see a lot is still departmentalized operations. And so there's different levels of intent expression and different scopes. an IT operator may express intent that relates the end devices to the applications. And this is really what we're very interested in, because we hear from you a lot that the main goal is really of the network to connect these end devices to the applications wherever they are. So the intent expressed by IT operators may be very different than the intent expressed by a network operator who's concerned about maybe their WAN routers or their campus switches and wireless access points. And again, that's one of the reasons why we have to think about intent verification, make sure that maybe different organizational teams don't have different policies that come out here that are conflicting maybe with other teams or with other domains. Some of these intent expressions may actually be constrained to a particular domain, and that's fine. That's actually easy for us, right? If you have, let's say, a WAN policy only, then great. You're only dealing with one domain, a lot easier to handle than maybe a multi-domain policy that comes out of an abstracted intent expression. So, second function, automation. Today, in an enterprise network, especially in campus and branch environment, DNA Center is our environment to automate the intent and to drive it into the network. So we have sophisticated capabilities in DNA Center centered around a set of workflows, a design workflow that you'll see, a policy workflow that we'll use quite a bit in the demo, provisioning and assurance as well, that basically can not only capture the intent, but then also drive the resulting configurations that we compute in DNA Center into the network elements themselves. So we do that under the hood for you based on workflows. That's our environment. Under the hood, what DNA Center is, it's basically got two main software stacks that implement intent-based networking. On the left here, you see more the automation stack, and that would correspond to the intent activation function in my generic diagram. And on the right here, you see the analytics and assurance stack, and that would correspond to intent assurance or intent analytics in the overall architecture. So both the software architecture in DNA Center reflects that. It's based on a cloud technology stack itself. So under the hood, we have basically the functionality implemented in containers running on Kubernetes. We're using Elastic Services extensively, Cassandra, MongoDB. So it's all basically cloud-based, state-of-the-art technologies that DNA Center is using. And the intent capture function would be reflected here in that solution in the user interface, as we will see. Now, maybe elaborating a little bit more on how do we take that captured intent and then arrive at a configuration. Because remember what Mark said at the beginning, today you already do this in your networks. How you do it in your heads. You receive maybe a request to implement a new service, provide access to a new application, and then you have to do the translation into, oh, I've got my Catalyst switches, my routers, my access point with software version XYZ, hardware capabilities A, B, C, and you do the derivation, probably often taking a few days, in order to come up with a valid CLI-based configuration that you then automate into the devices. In DNA Center, we do that through a series of model transformations. So we basically have the user interface that you interact with, and internally then we have what we call a service model that has a Yang representation. And that is basically taken through a series of transformation into then device models that can then be turned into very specific, in our case, still in many cases, CLI configurations that we automate. So we go through a series of internal transformations of an abstracted user interface-based expression of intent in order to derive the valid CLI configurations. I basically cooked up an example here on the left. So let's say your expression of intent is, I want to deploy a software-defined WAN between sites A, B, C. Then we would have a so-called customer-facing service model, CFS, that would say, oh, for that service, I need basically IPsec encryption because I'm in an SD-WAN environment. I want to do performance routing because I have multiple transports. And I want to be application aware, so quality of service needs to be part of that service as well. And that is now a little more granular than than the abstract expression of intent. And we can then take that again down to a next level of detail and say, oh, on my path, I have to touch router R1, switch S1, or whatever devices I have. We know what they are in DNA Center because we have the inventory, we have the hardware capabilities, we have the software capabilities. And so we basically correlate that information with that intent in order to then come up with the right CLI configuration for, let's say, an ASR 1000 or a Catalyst 9000 switch, and that can then be pushed down into each of the respective elements. So that's kind of what happens under the hood and how we get from a abstracted user interface-based expression of intent into the CLI. Now, third function, very important, assurance. Because without assurance, you kind of only have automation. And what we want to do here is, first of all, we want to do a lot of verification. So collect data from the network and correlate it and figure out what is that data, what is the network doing right now. So we collect telemetry. The goal of the telemetry, however, is not just, like I said before, to throw it back at you maybe in a nice series of fancy user interface screens, histograms, pie charts, etc., but to make sense of it. And in order to do that, we do a lot of analysis and filtering. So we filter out data and try to generate insights that maybe point to a particular problem or show you a particular state. And that's what we basically mean to do here in the second element of the assurance layer. Today, if you've seen the keynote, we have announced the use of machine reasoning and machine learning. So that's now a new capability in DNA Center that will help us do an even better job at delivering intent-based networking. We've been using so far technologies like statistical analysis, correlation, pattern matching, and other heuristics in order to come up with that. So verification and insights is basically the more detailed function of collecting data and filtering it out and understanding what is going on. And what really differentiates an assurance from just, in quote-unquote, analytics is to then tie it back in with the original intent. Because the goal is to figure out, is that intent that you express, is it actually met or not? So we go back to the original intent expression, maybe our internal model, and then verify that that intent is or is not met. And furthermore, if it is not met, we want to provide you with suggested actions or even hints and indications on how to correct to get it back into compliance. Our ultimate goal is to maybe even automate that and say, kind of have the vision of a self-correcting network, make sure that at any point in time that intent is met and allowing the network to do that itself. A lot of people usually get a little nervous when we propose that the things happen in the network on their own. But you could imagine maybe an interim step where you say, I have the same problem popping up, maybe in different parts of the network. It's got the same symptoms. It's got the same solution fix, same remediation. We could maybe have an interim step where we say, click here to fix. Or you fix it 3 or 4 times, and then you say, OK, fine. fix it automatically, but let me know about it. So I don't want you, controller, to do stuff autonomously without at least my awareness. So there's ways maybe to do that remediation and closing the loop in a smart and acceptable manner. So a little more detail on how that works today in DNA Center, that derivation of assurance. And imagine here the scenario is you get a support call from a user that says, I can't access a certain application. And so we collect NetFlow data from all our network elements. And in our Cisco switches and routers, we also have the capability to do deep packet inspection. And so we use deep packet inspection in order to find out what application is it. In this example there, I would have maybe a WebEx application, an SAP application that is running on the path that the user reported. We can then talk to the DHCP, DNS, IP infrastructure, so basically our DHCP server, DNS servers, in order to derive more information about what is actually going on here, and for example then correlate the IP address to the actual end user, and in case of ICE, even figure out that user has other devices. So maybe there are other effects as well of a potential impediment that happened in the network. We know the topology, of course. DNA Center knows the inventory of all network elements and how they're connected. So we can tell where that user is connected to. In this case, maybe a wireless access point, which wireless LAN controller the traffic is hitting, and also what routers and switches are sitting on the path. And so we can take information from those devices and again feed it into that correlation algorithm in order to derive, basically come up at the end with potential issues that may have caused the original problem. So we're basically collecting data from all points, all possible points in the network that we're allowed to, and then try to make sense of that. We store this, what we call contextual property and correlation graph, also as a time series. So what you'll see in DNA Center, which is actually very powerful, is that you can go back in time. And the motivation is very simple. If you get a user support call, you can actually point the DNA Center data to the exact point in time when that issue was reported, rather than then have to go, oh, can you reproduce the problem? Can you give me a packet capture, and then try to find the cause of the issue after the event happened, which is sometimes very hard to do, especially if it's an interim problem. So basically, to summarize, what is happening in an intent-based network as opposed to a traditional network is that we are focusing on these three functions, capturing an intent in a much more abstract manner, providing automation functions to drive the resulting configurations into the network elements, and continuously ensuring that the intent is met. A bit of an eye chart here, but I thought I'd flash it up, make you aware of it, where we basically compare the traditional network operations with an intent-based network operations. And you see here there are quite a few differences. When we look at architecture in a traditional network, we would be thinking more about device by device, box by box kind of operations. In an intent-based network, we look at all of the network elements as a system in themselves, sort of as one entity that we can understand and operate on. Translation, as we said, today is done based on operator experience. In an intent-based network, we do that with that intent translation function, and there's other significant differences here that we're trying to basically move to when we go to intent-based networking. So Mark, I think it's time to actually show them that what we're talking about is not just PowerPoint, but is actually real. We have three use cases that we wanted to show you. Probably only going to focus on two here. One is about access control policies. Everybody aware about what an access control policy is? Or is this a new term for some of you? We're all good? So that's one example that we have. And then the other one, which is my favorite really, is the application experience example in DNA Center, where we can set application policies, basically saying how relevant an application is to your business, drive the automated QoS configuration into all of the relevant network elements, and collect assurance and tell you exactly how that application is faring at any point in time using the DNA Center assurance function. So, Mark, should we maybe start with the access control policies quickly, or you want to do application? Let's do application.
I want to do app policy. So let's.
And are you on your lab system now, or are you actually on the Cisco Live Network Operations Center?
This is a lab system, so you can see I don't have a bunch of clients or a bunch of endpoints here. So I've got a few devices here. I'm not going to change the real live production network, but I might jump on the production network and show us some app policy stuff.
He has a tendency to jump in the deep end and actually use real production systems.
And change things on the fly and make Matt really, really nervous about
it's an interesting experience when he does that.
Control.
So what do we see?
So I'm in a DNA center that lives in my lab back in San Jose. So hopefully we sacrificed enough chickens and the network stays up. I've been watching things bounce here. If you're wondering why I was typing away, because my VPN would go up and down here a few times, and so I was trying to make sure that I really had connectivity. So I want to go to the policy portion of DNAC. So I jump from the home page to policy, and now inside of policy, I want to go to application policies. All right, so 3 clicks down, I've now come into an environment where I have policies that I can configure, and easy enough, I can go add an application policy and give it a name. Now I'm actually going to back out of this portion of the network and go with the one that I created, because I have a test policy there that I want to manipulate. So I'm just going to say close here and get out of that. And I'm going to select the policy that I have in this environment, and then I'm going to edit the one that's there. But there was a question right away, like.
Yeah, so that, when I'm looking at this list, it says like there's 12 applications. Is that list predefined, or is that based on information that's been gathered from the network already?
So this is not based on information that's or that has been gathered from the network relative to the applications. The applications that are being presented to you here initially are the apps that application recognition or NBAR knows about, right? So by default, NBAR can recognize somewhere around 2,700 apps, a whole bunch of those, 1,800 or so being encrypted applications even. And what we've done for you as a starting point for application policy, notice that it says use the CVD queuing profile. So it's taken the best practices that are included in the quality of service CVD. Have you guys seen the book that Tim Seghetti has published? It's about 6 inches thick, and it has everything that you would ever want to know about quality of service but we're afraid to ask is documented in that book. That same logic has been brought forward here into this application that allows you to very simply express, hey, there's applications that are important to me. Those are the ones that are on that side of the screen that are called business relevant applications. And NBAR by default has applications that it can recognize that it's put in the business relevant application group.
So we call these application sets, right?
Yep, application sets are just groups of applications because you can move them.
With similar behavior. It would be a little too cumbersome to deal with, 1,500, 2,000 application lists and sort them one by one. So DNA Center groups them already with similar properties, and that makes it a little easier. Question?
Integration with other vendors, like the Palo Alto has recognition, and Intel has some recognition. Is there any integration with those vendors?
So right now there's no integration. We do this with NBAR on our Cisco boxes. So that's where this comes from. These categorizations are standardized in the IETF. So the default values are based on IETF RFCs on how these different applications would be classified. But that is changeable, right?
Yep. Yeah, and I'm going to take you through an example of actually moving some apps around here and changing the way that the way that they behave and what is it that we're doing to service them. The other kind of interesting piece in the keynote, we showed integration between DNAC and ACI. So if you're running ACI in the data center, we'll recognize the application names that you give to the groups that you define inside of ACI in a future release. Like in the release that comes in July timeframe, you'll be able to do integration and see the apps that you define there. We are consuming the names that come out of ICE as well. So if you go into ICE and make a custom application definition in ICE and assign it a group name, that will also show up inside of DNAC so that you can write policy against it. Additionally, you see that we have this application registry here. I can go in and create new custom applications. So you have apps that are running in your data center that are not recognized by NBAR, but that are real applications. You can go in and give source, destination, IP addresses, even the ports that those applications are using.
Or URL.
Or a URL, and match against that application and create your own custom definition. So you don't have to consume this just as it comes out of the box. You can fine tune it. However, the default, well, you guys just saw my VPN bounce, so now let's see if it comes back and all is good. So the defaults are totally usable. Right? The defaults are designed to be fairly safe and benign, but if you have real kinds of business apps, NBAR classifies those or gives you these attributes that say these are business apps. It also has a whole group of applications that get just default behavior in your network, and then tons of apps that are consumer kinds of applications that you probably don't want to spend resources to protect in your network. And if there is some kind of a congestion point in your network, these would be the ones that are adversely affected or would have drops or get rate limited before the rest of your applications. So your class default are protected, and you're spending resources to do things to the business relevant apps, putting them in a bandwidth queue or in the priority queue if it's voice and video. And all of that happens behind the scenes for you from a configuration perspective. So one of the things that I want to do with this is show you that, remember we were talking about scope, right? You're able to say, what devices in my network do I really want to send this policy that I'm building against? In this example, I've selected my silver site that's in my test environment. I can even get more specific here, and I can say, you know what, I really just want to target my 9300 switch in this environment, so I'm going to say exclude these other two devices, and so I'm just going to target one switch in the test environment as we make changes, and so it's going to save that, and that's all happy now that I've changed my scope. And so the first thing I want to do is let's just do a pre-check, right? And so I want to make sure that the device in my network that I want to push policy to is able to take this policy. And so I can run a pre-check against this thing. And
that usually takes a little while, no?
Yeah, not that long, right? It works. So here you see that the two devices that I went into my scope and said I didn't want to touch, that it told me they're excluded. And it tells me that for these devices, or this device, that it's all good. I could push policy to it based on the policy that I've already configured. I have the right licenses, I have the right image, all the functionality that DNAC wants to deploy, I could. Notice over here I get the nice Go Deploy Right Now button, but I don't know that I'm that gung-ho, so maybe I've got my CCIE badge on and I want to go see what this thing's going to do to my network element before I actually go provision that in my environment. So I want to do a preview, right? So tell me, what are you going to go push to this switch, right? So now I'll come up here and I'll say generate. This will take a second because it is building all of the CLI that it's going to go push. And remember, we're doing that 12-class CVD-based quality of service policy that you would have never written and deployed by hand. But when the controller is automating that piece of work for you, you don't need to have trade-offs between complexity and number of lines that you have to generate at the keyboard to really protect your application. So we can use 12 classes. And so it built me a pre-configured set of configuration for my environment that is the reflection of the policy that I expressed over here in this environment, where I said, I have a bunch of apps that my NBAR application recognizes, and now I want to mark those applications with a specific DSCP value as they come into my network, and then, hey, by the way, I want to service those applications outbound according to the QoS policies. Remember, I just took all the defaults, the CVD, but I could go in and modify that policy and say, in my environment, I need more bandwidth for streaming video than some other class, and I can use the tool to change that and very easily generate a separate kind of policy. Look again over here, it's telling me I could go deploy, so I could hit deploy and push it live to the network right now. But you know what? I looked at this and I said, hey, wait a second. I've got an application that I want to change from one group to the other.
Can I just make one comment? So
yes.
The slide that I had up about the example about the model transformation, that's exactly what is happening here. This is our abstracted expression of intent. There is no reference in this user interface about what catalyst switches you have, what routers. You're just expressing intent based on the application, on what you want your business to do. And DNA Center under the hood then went and correlated that with the devices that Mark has as an environment and derived the CLI through this successive set of transformations.
Got a couple questions. So he was first back here.
Sorry, I was going to ask, is there a way to separate out access points, or rather access interfaces versus uplink interfaces and stuff like that? Like, for example, when you're applying QoS policies, it might be different for access versus uplink.
Yeah, so you can exclude down to specific interfaces your environment as you apply policy, and you could create those, although not recommended, right? The whole idea here, this isn't a network element manager that is a place for you to create the QoS policies that you've been developing by hand that you know and love and then force them into the tool. You really want to take advantage of the intent and say, these applications are important to me, these applications are not, and use the intelligence of the controller to build the right policy upstream, the right policy downstream, the right marking policy, and not think about it as one network element. Like, for purposes of the demo here, we're doing one element, right? But when you want to deploy this across all the route, switch, and wireless devices in your network and keep them consistent to that behavior, you want the controller to go generate all that and not do it. So don't think of the tool as a way to recreate the QoS that you would have done in Notepad and then paste into a router or a switch.
But it's actually a perfect segue to what we're going to show right now, which is the customization, right?
Yes. So in this default configuration, I've got some consumer-based browsing applications, and one of them that I want to click on here and do something interesting with, there we go, is Airbnb. So let's say, for example, in your business, you need to access Airbnb, so you don't want it to be in the scavenger class in your network. You want it to be at least in class default. So you want to make this more relevant and make sure that it gets protected and it's not one of those applications that gets dropped in your environment. So I'm going to edit the details of this application. Notice that we say it's a transactional application, so if we are going to protect it, it's going to go with all the other transactional apps. Right now, it's in the consumer-based browsing class, which means it's falling into the scavenger class or the not protected, and I'm just going to move it up one level. So I'm going to move it over into now my general browsing group of applications. I'm going to save that. And this is changing now the controller's definition of what apps go where. And when it gets that all saved, now I'm going to do something interesting. I'm going to go back to preview, right? So I just want to see what was that going to change in the configuration on my switch in my lab. So I'll regenerate that CLI based on having made that one little simple change to say this stuff should not be in class default, which is the default setting in NBAR, but go modify how NBAR behaves on that device and put them in my class default or non-protected but not scavenger class of the environment. Now the reason that I picked Airbnb is because I knew this would go at the very top of the config and I'd be able to easily find it. So you see here that it went in and made this configuration change to say the attribute for Airbnb will be business relevant and then applied it to Airbnb. So IP NBAR attribute set Airbnb BR2, which now is business relevance default instead of business relevance irrelevant, which means if and when we recognize NBAR with these match statements here, when it recognizes Airbnb inbound on the network, it will now not mark it to scavenger class, but set it to default, which means it'll get serviced in my default queue with all of the scheduling configuration that's getting done across the network. In this example, it's only on the uplinks that scheduling configuration is getting applied differently, but there you have the ability to change that. And again, I could click on deploy and it would go push this to my network element. I don't know how exciting that is to see how long it goes and pushes CLI to a device.
Mark, there's a question here.
Yeah, okay.
And how do you check afterwards? If you deploy I believe you have some tools that
Yes.
you will be able to see specific application Airbnb to monitor.
Yes. So the question is, hey, how do I know that this stuff is working, right? And so now, Mr. Faulkner, get nervous.
Oh,
this is
your real.
This is the production cluster in Europe, where I'm looking in on a site. I picked a small site, and there shouldn't be a bunch of people there.
Do we
right
have
now,
anybody
so it
from
should be
Bratislava
okay.
here? Because it
Yeah,
seems
so
to be the Bratislava. Anybody from?
Yeah. No. So we're currently deploying DNAC assurance in the Cisco production network, and I wanted to, in my lab, I wouldn't have any applications for you to see how are those applications performing or not. So I grabbed a small site in Europe that it has DNAC assurance deployed. This is a gold site in our deployment. Actually, I think this is a silver site, but anyway, it's a small branch office. And I'm running DNA assurance across this. We haven't yet deployed software-defined access or software-defined WAN at this location, but I'm DNA ready. So I've upgraded to Catalyst 9K switches. I have a 55 or 4451 router at that location and 4800 APs deployed there. And I've turned on the performance monitoring portion of DNAC through the telemetry quotient. So it's running perfmon and ART on that branch router that's sending NetFlow into DNAC, so that all of these applications that it's recognizing via NBAR are able for me to have performance characteristics about those applications. It recognizes a whole bunch of apps, tells me how they're performing. It focuses on giving you information about the applications that you've marked as business relevant, and will spend resources on those routers to monitor performance of those applications, all the way down to loss, latency, and round-trip transaction time on those applications, which is what perfmon gives you in the routers. Now we're exporting that via NetFlow into DNAC, and here it gives you the ability to visualize how those apps are performing, and we can see all kinds of different applications that are there. The ability to filter down and look at different apps. I'm not going to go poking around too deep in the production system, but I wanted to show you that, yeah, absolutely, we tie those two things together so that you're able to see performance of the applications and what's happening in that space.
So this is why we think that application policy intent is like a perfect example. We've seen the user interface to express it without any detail about the network. We've seen the automation and now the assurance. So it's really all three aspects of an intent-based network that we're implementing here in DNA Center. You had another question.
Yeah, I have two questions. So I saw before when you created this policy, you had targeted a site and then you were selecting switches and whatnot. So then it's just based on that site. So if I had other networking devices like wireless LAN controllers and routers included in that site, this application policy, they would be included in this policy, right? And would generate the config changes for them?
Yes.
Yes.
That's how it goes.
Yep.
Okay.
Yeah. So I wanted to scope it down as small as possible for a demo, right? But because it takes longer to go generate all of those previews and all the showings, but I could select an entire site, route switch wireless, all the devices at that location have this common policy, and say, boom, apply.
So it would generate like the ABC profile.
Yep.
Yes.
I get the answer to that on Apple Watch.
Don't-
I didn't say.
yeah.
Siri tried to answer.
Skynet.
So in this profile, you had done a pre-check. Now, is there a way, and we could see what devices were being touched and then what settings are associated, right, with that config? Is there a way to generate a report on that to because most organizations have like change control or change board, where I gotta go and say, you wanted this services deployed, here's all the devices they're gonna be touching to enable this. Right?
Yeah. So you really do it in this scope setting, right? When I select a site,
Yeah.
I then drill into, once I select that site, so let me pick another one. Let's pick the sandbox. Then I drill into and say, those are all the devices in that sandbox.
Yeah, but how do
right?
I get that out into a report that I can take to this other department? and
yeah,
say,
you're-
here are all the things. You know what I
So
mean?
we're kind of a step beyond. The real way to get that done is through the integration with ServiceNow, ITSM integration.
Okay.
And it's not really part of this demo. I'm not set up to show it, but you should go see on the showroom floor down in World of Solutions. I know they have a demo down there on ITSM integration, and it's demonstrating before you hit submit to actually go make a change, it goes out and asks for approval in ServiceNow and brings all the devices that are going to be changed and the changes that are going to be applied, and lets you go through an approval workflow in ServiceNow before it returns control back to DNAC for DNAC to submit. That's something that is shipping in the 1.4 release. Early versions of it are available now in 1.3, but the full-blown support of that really comes on strong. In Cisco IT, we are actively investing in the development of that interface. We do all of our stuff through change control via ServiceNow, and so nobody in Cisco IT is going to hit submit here without it having gone through approvals. Now, they might do the approval work ahead of time and use this at deployment until we get all of that integration put in place, but that integration is coming. That's part of the story.
So you talked about a WAN site, so would it have a way for you to tell it, like your service provider probably doesn't provide 12 classes of service, so is there a way to input
Yeah.
classes in the markings that they support?
So
Yes.
hanging right here is this profiles, and I didn't take any time to add them, but you can actually go in and define the profiles that your service provider gives you, right? So you're able to say, these are the classes, and this is what I need to queue into there. And actually then, once you set that up, yeah, once you set all that up, it follows then the CVD guidance on how to collapse those 12 classes into the appropriate ones, gives you the opportunity to remark or not,
Yep.
depending on the model that you have with your service provider. So that has been taken care of ahead of time. So you're able to define that and then apply it to the right interfaces.
There was another question somewhere?
Yes. What if somebody makes a change out of band from what
Then you go smack them on the head. No, it's an interesting oh, I got to get out of this.
What if they're correcting something that DNA Center got wrong?
Yep. So that's a great, hey, what happens, right? So today, DNA Center does not go change anything that you do out of band back in your environment. So you're able to go make changes and change the configuration of a network element and drive it out of policy because we haven't locked you out of CLI. There is the ability in inventory to see what config is there. I'm not set up for that. Like I didn't do that in this environment. But if somebody goes and changes a network element, and actually I'm going to get off of the production machine before I do something bad. The ability to see that the network element is not currently configured the way that policy would have it appears in the inventory page. So you can see that you're out of sync and that you would need to reprovision it to bring it back in, but it's not taking action to go do that automatically. Under development is a configuration, what's the word that I'm looking for?
Manager?
Well, no. Yeah, it's part of the assurance story. And
Yeah.
anyway, the ability for you to run reports that tell you, are you not, and to set rules that say that, like, it's an exception, put it in the fix it now space and then automate that job so it comes back, or this it really is a troubleshooting problem. So save it, leave it there, and then you can go off and work on your policies and your profiles to bring it back in spec later and reprovision to do it. So that work is coming. Today it's pretty rudimentary. You know that it's out of sync, and then you have to take action to put it back or not if you need to. You bet.
To wrap up.
All right, are you going to do your piece?
I think we're going to have
Okay.
2
we
minutes.
had so much fun.
Yeah.
So we'll just keep taking questions rather than try to do another demo.
Or
You're going to wrap up?
yeah, let's wrap up and then take questions. No?
Okay.
Which button do I push?
You push the red one, that one.
4?
Yep.
So this is what basically happened under the hood, right? When we did this application policies, and that was just one example. Don't leave yet.
So if you do leave, please fill out the survey. 5s are good.
So we have a bunch of other examples that we wanted to show you, but we thought it's probably better to deep dive into the one and do it properly than run by too many. So basically, we think we're at a really exciting journey now in enterprise networking with intent-based, moving traditional networks to intent-based. I think the thing hopefully you will remember, an intent-based network basically focuses on an abstract expression of intent, allowing you to maybe define how the network should behave that is a lot more aligned with your business. It's got a lot of focus on driving automation functions and automating that capability, that intent into the network. And don't forget about assurance. This is really important in any intent-based networking. And as you saw in today's keynote, what we focus a lot on by continuously enhancing our machine reasoning and machine learning capabilities. For us, it's the beginning of a journey. We focused a lot on DNA Center today, so campus networking, route switch wireless. The same capabilities actually apply in the data center. So if you talk to our colleagues over in data center land, in ACI, very similar concepts, same functionality they're focusing on, and you can expect a lot of enhancements from us going forward in this whole journey going forward. We'll be on WebEx Teams. If you have a question that we haven't answered, you thought about, maybe over coffee or tonight over a beer, hit us up on WebEx Teams. We'll continue to monitor it. As Mark said, we'll stay in the room until the room is empty, pretty much. Yep. We hope you enjoyed the session, and please enjoy Cisco Live. Thank you for joining.
Have a great day, guys.